that is our electronegativity. So electronegativity. Down the group, electronegativity will definitely decrease. Why? Because down the group, what is happening? The size is increasing, right? And if the size is increasing, the effective nuclear charge will decrease, and also the electronegativity will also decrease. And nitrogen is the one of the most electronegative atom in the whole periodic table, right? Fluorine, then oxygen, then it is nitrogen. So that is the trend of electronegativity. Moving further, our next is metallic character. So that is already, down the group what happens. If the electronegativity is decreasing, electropositivity will definitely shows a reverse effect, right? Electronegativity and electropositivity are reverse of one another. So if going down the group, if my electronegativity is increasing, my electropositivity will be, electronegativity is decreasing and the electropositivity will be increasing, right? So as you can see, nitrogen and phosphorus are your non-metals, while my arsenic and antimony are my metalloids, while bismuth is my metal, right? So if the electropositivity is increasing, your metallic character will also be increasing. So our next property that we are going to discuss is the melting point, right? So melting point has a very different trend. It is going to be a very different trend in the case of the our group 15 elements. First, it is noticed that going down the group up till arsenic, my melting point increases, right? So we can assume why it is increasing, because the size is increasing, and that is why it is, the melting point is increasing. But we also know in case of S block elements, going down the group, our melting point decreases, right? So why it is increasing over here, right? And if we will see further, even to complex the things, we can see that our the melting point after arsenic, it decreases up till bismuth. Why is that, right? So there are two forces which are counteracting each other. The very first one is the size. Then it is the crystal lattice in which atom or your element is crystallizing, right? So this is the reason. First, because of the size is increasing, what is happening? On increasing of size, because the van der Waals forces will increase, your melting point should definitely increase. That is the common logic says. But second factor, which is the one of which also affects the melting point of any solid compound, that is your metal in which it is crystallizing, right? So down the group, when we talk about the S block elements, if you people know, lithium crystallizes in the FCC, while the cesium crystallizes in the BCC structure, right? So that is the reason in which crystal lattice it is, that also affects the melting point of our compound. So for the group 15 elements, melting point first increases till arsenic, and afterwards up till bismuth it decreases, right? Let's see our next property, that is our inert pair effect. Inert pair effect, I have already explained you in very much detail in the group 13, right? What happens? What is inert pair effect, if you remember? It is the metals which are heavier, or if I say heavier elements, which are starting from the period number 4 to period number 6, tend to show that oxidation state which is 2 less than that of the group oxidation state, right? That is known as the inert pair effect. If you remember, I told you why inert pair effect is there, because the electrons which are residing, let's say if I talk about the bismuth, the electrons which are residing in the 6s2 orbitals are so much closer in the energy to the 4f and 5d, that and 4f and 5d have a very poor shielding effect. So the effective nuclear charge experienced by the 6s2 electron is so high that rather than showing the higher oxidation state, they remain in the inert form, and they tend to show inertness, and the maximum the oxidation state is 2 less than that of the group oxidation state. So bismuth also does that, if you remember. Bi 5 positive is less stable than that of the bismuth. Bismuth 5 positive is less stable than bismuth 3 positive. So now I what kind of questions they can ask you on this one? So if I ask you a very small question is, which is better reducing agent? This question I can ask you. In between Bi 3 positive and Bi 5 positive. Instead of, let's say, reducing agent, you can use oxidizing agent. Right? Which is better oxidizing agent, right? So bismuth 5 positive, right? Because bismuth 5 positive always want to go into the +3 state, that is, it is reducing itself, so will be oxidizing the another chemical compound. So these kind of question they can ask you in both JEE and NEET, right? So that is the effect of the inert pair effect. These are the consequences of the inert pair effect, which I have already explained you in detail in the group 13 and 14, right?